Hello everyone, welcome to Reactify Labs. Today we will talk about another behavioral design pattern called command design pattern. So let's start by writing it. Command pattern. Okay, and as the ritual is, we will start with the definition, the technical definition of this pattern. So the technical definition says the command design pattern is a behavioral design pattern that turns a request into a standalone object that contains all the information about the object. This transformation allows us to parameterize methods with different requests, delay or queue a request's execution, and support undoable operations. Okay, I know this is very technical and many of us wouldn't have understood it. Even I didn't understand it, what I said just now. So that's fine. Let me explain what the situation is when a command pattern is used, or command pattern can be very helpful. Okay. Hmm. Before that, no. Okay. Let's see. Let's see where it can be used. So we have a situation where we have our house. Okay, and it has different rooms. Let's say there is a bedroom, there is a kitchen, there is a living room, there is a bathroom. You understood it, right? A house has many rooms. Each room has something common, which is light. Common as in, like, every room has a light, not a single light for all the rooms. No. Every room has a light, right? So let's say we have to make a light installation in our room. Okay, we want remote controlled light. So what we can do is we will have a class of light, right? And it will have a string location. Location means just to tell this light belongs to which room. Okay, and there will be a light constructor which will contain the string of location, and this constructor will just assign this location as the value. This dot location equal to location. Correct? Good. Now, this light has two functionalities: on and off. On and off. Correct? Right. Then let's say, uh, just to show it here, when the on is called, we will print on, and when off is called, we will print off. Right? So that's it. And this closes our class light. You may ask that we can have multiple functionalities, like increase the intensity of the light, decrease the intensity of the light, change the color of the light. Yes, we can do that, but for the sake of explaining here, I'm just keeping it short and keeping it limited to only on and off. Okay, good. Good. Now, what's the problem? So there is no problem, right? Let's say we have to make something like, what do I say? Mm, or actually, no, because this will not be clear. So instead of printing, we will print this location plus on. So we know for which location the light got turned on, right? So location plus off. Okay, great. Now the problem is not the problem. Let's say let's expand it further. So we have to install the light in different rooms. So what can we do? We can make this class as abstract class, right? We can make this class as abstract class, and we can um, inherit these. Uh, not inherit, we can extend this with, let's say we have a new class called bedroom light. Okay, we have another class called kitchen light. We have one more class called living room light, right? We will have these things. Okay, now what happens is each of these need to implement their own on and off functionality, right? Each of these need to implement their own on and off functionality. And what more we want is we want a remote to control the lights, right? We want the remote to control the lights. So if we have our own, first of all, this on and off will be deleted from here because it's not common. It's um, specific to each location. So we have to remove it. Okay. Second is when we have to control it using a remote. Okay. So what can we do? We can do something like there is a remote and it has, again, let's say remote has something like press this button or press on button. So when this on button is pressed, this bedroom light gets on. So press on button for bedroom. We need to do that. Similarly, if we have to turn it off, we have to do press off button for bedroom. Okay. These things we need to do. So for all the rooms, we'll have to make keep all these two buttons, right? For every time. So if we have, let's say, if we have a very big house and we have, let's say, 10 rooms, for all these 10 rooms, we need 10 rooms, including like 4 bedrooms, 2 bathrooms, 2 kitchens. Similarly, with including halls and all, let's say there are 10 rooms. So we'll have 20 buttons for only lights on and off. Similarly, 20 buttons for fans, 20 buttons for ACs, right? So it will be too chaotic. And also, as you would have heard in the definition, if not, I'll read it again, the last line of the definition. This transformation allows us to support undoable operations. So if we have to undo, for example, let's say we pressed on, okay, and we pressed off, we do not want to do off. So what can we do? We can press on again or we can just do undo, right? It's here, it is simple, but it's possible that it will always not be this simple, because let's say if it was for the for increasing the intensity of the light, it will have levels, for example 1 2 3 4 5 6, and you accidentally pressed from 6, you did 10, and you do not remember what the last thing was. So at that time you cannot just go and check each different intensity. Instead, what you will do is you will just click on undo and it will bring you back to the previous intensity, right? So this is the problem that occurs, and this is something that um, a command pattern is going to solve. Okay, so how it will solve that? I will remove these, and so till this point it will be common. Now what we will do is we will make a command. Okay, so there will be an interface called command, and it will have two functionalities, two methods called execute and undo. These two methods will be there, right? Now we are going to do something unusual here. Again, referring to the definition, the command design pattern is a behavioral design pattern that turns a request into a standalone object that contains all the information about the request. The catch is request to standalone object, right? A request is converted to a standalone object. So basically the request here is to either turn on the light or turn off the light. So we will have an object for turning on and turning off the light. So light on will be one object, light off will be one object, right? This is what it means. So what we are going to do is we are going to create a class called light on command, and this is going to implement this interface. Okay, it will have something. What? It will have an object of light, light. It will have a constructor, light on command, light, light, and this will initialize it. This dot light equals light, and we will have to override this execute and undo. So there will be an execute, and what this will do is this will call the light dot on, this on that is here, right? Light dot on will be called, and similarly we'll have an undo, which will do what? Since the light is on, then the undoing will turn it off, right? That's it. Similarly, we will have a class to turn off the light, right? So class light off command. It will be similar to the light on command, only this execute and undo will differ, right? So I'll not rewrite this, assume that it's already here, and we will have an execute which will just turn light dot off, and we will have undo which will turn light dot on. That's it, right? Now one more thing. What did we discuss? We discussed about a remote, right? We will have a remote to control all this. So before moving forward, remember there are 4 more components to this command design pattern. The not 4 more, the four primary components. So first component is command that I have already made here. If you see, this is the command, right? This is the first component. We will have another component called concrete command. Concrete command. Concrete command is this light on command, and light off command are concrete commands. Then we will have a receiver. Receiver is at this moment who is receiving this command? This light class is receiving this command, right? So this is our receiver, and there is one more invoker. So in this case, the invoker is remote. Who is going to invoke this light on and light off command? The remote control is going to invoke that, right? So we will have a remote class. So we will have a class called remote control or remote. Let's make it remote control. Okay. And what it will have is it will have a list of commands. So let's say there will be a stack, because obviously when we do undo, we use stack. So there will be a stack of command, and it is called command history, or let's say commands. That's it. And what remote control does is remote control has to execute command. Okay. So remote control executes command, and it will be passed with command and command. So when remote control calls execute, what it will do is this command will call its own execute, right? We have an execute in command, right? Here. So this execute will be called. Similarly, when undo is called, in that case, what happens is it will check this stack. If the stack is empty, if commands is empty, then do nothing, right? And if it is not empty, if commands is not empty, then what we will do is we will do a commands dot pop, right? And whatever this will return, we will click and undo on it, right? Commands dot pop will return one command, and on that the undo will be called. For example, let's say the last command was turn light on. Okay, last execute turned light on. Then this command, in this command at the top will be light on command, right? Light on command. And when we click undo, what happens is, and below it will be something something something. When we click on undo, this light on command will be popped from the stack, okay? And after it popped from the stack, the undo will be called. This undo will turn the light off. So this is how this happens. Now let's see how it solves our problem. So we have all our four components, right? We have our command, we have our concrete command, we have our receiver, and we have our invoker. Now let's go to the client which is going to use our this design pattern. So we will have a client which is going to use it. Let's take the example of two rooms. We have a living room and we have a kitchen. So we will use the light constructor to create a kitchen light. Kitchen light equal to new light in kitchen. Similarly, we will have a light of, let's say, bedroom equal to new light in the bedroom, right? Now what we will do is we will create light on and light off command objects. So there will be command bedroom light on. So bedroom light on will create a new object. So we will use light on command, obviously. Light on command. And if you see here, we will use light on command. This light on commands constructor will use the object of light, right? So it will use the object of light. So which light we are going to use? Since we have bedroom light, so we will use a bedroom light object. Okay. Similarly, we will have one more command for turning the bedroom light off. Bedroom light off equal to new light off command, and we will do with bedroom light. Bedroom light. That's it. Now, if we just create a remote control, because obviously we need that, remote control object called remote, and it will be a new remote control object. So in this case, this all it will do is remote control will call execute. It does not have anything else, right? It will call execute. When it calls execute, it will use the object. What command does it need? If you see in the parameter, it takes the command. So what command does it need? It needs a bedroom light on command. Bedroom light on command. So as soon as this remote calls this bedroom light, calls this execute with bedroom light on, what happens? Let's see the flow. This bedroom light on dot execute will be called. Okay. Bedroom light on is an object of light on command. It means it will go to the light on command, and here bedroom light dot on will be called, and the light of the bedroom will be turned on. That's it, right? Similarly, same thing we can do for kitchen. We will just replace this bedroom with kitchen. If we replace this bedroom with kitchen, so, and what we can do now is remote dot, sorry, this bedroom light also will be replaced with kitchen light, because we have created this thing here, and this remote execute will be called with kitchen light on or kitchen light off. So it will be done. So if the light is already on, it will remain on. If the on is pressed multiple times, if the light is off, it will remain off. If it is on and off is pressed, it will be off, right? There is just one more thing left which I need to show you, which is undo. Let's say somebody turned the light on but does not want to press the off button, or the off button has gone missing. So what it will do is it will just do remote dot undo command. Undo command. So what remote will do is, here, see, in the undo command, it knows, like, let's say last 5 operations were bedroom light on, kitchen light on, bedroom light off. Okay, let's say these things. And what happened was, by mistake, this bedroom light off was called, and the person wanted that, okay, the light of bedroom should not be off. So it will just try to undo this operation. So this undo will be called. This from the top of the stack, this will be removed, and bedroom light off will be, this bedroom light off object will be created. And here, if you see, it will go in here, commands.pop.undo means bedroom light off command. It will go into the light off command, and undo will be called, and it will call the light on with bedroom light on. So the undo will be called on the light off command, means bedroom light off command. Undo will be called on bedroom light off command, and so it will call bedroom light off command dot on, because in the off, undo operation turns on something, in the on, undo operation turns off something. So this is the explanation of what was this command design pattern, right? And yeah, it's a little lengthier than the other design patterns, I know, but if you understand the concepts, it's very easy. If you see here, it has made our task very easy. Instead of creating one class for bedroom, one for kitchen, one for living room, one for bathroom, one for each room, we don't need to do that. We only created this one light on, light off command, and it can be used for all the rooms. Just keep in mind that there are only four major things here, four major classes: command, concrete command, receiver, and invoker. And the client will just use their combination to do anything. That's it. So I hope this clears the command design pattern. Thank you for watching. Please remember to like, share, and subscribe. I will see you in the next one.